Hello, so for this assignment, I'm going to be finding the isomers of heptane. And so heptane has 7 carbons in its chain. Okay, and so the ones that I've chose, I'll try drawing it out. Usually with isomers, they have the same chemical formula, but different structure. All of these should have 7 carbons and 16 hydrogens, but we could try to check. 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And in red, I'll try to show where I'm seeing the hydrogens. I'll just put like a dot. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so we have carbon, 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 2, 3, 4, 5, 6, 7. Okay, so that's 16. Okay. Sorry about the dogs barking in the background. I hope that's not too that's no problem. Well, hopefully you can't hear it. Hopefully you can't hear it. Okay. So they all have the same chemical formula, just different structure. And so now let's get into the naming. Choose a different color, I guess blue. So for this one, we have an ethyl group on it. And then it's 1, 2, 3, 4, 5. So pentene. Ethyl. And either way you go, it's going to be on the 3rd carbon. At least that's where I chose it to be. Then the next one, let's do yellow. So 1, 2, 3, 4, 5. Pentene. 1, 2, 3. Back. 3, 3. Dimethyl. Hope you can read that, but that's 3,3-dimethylpentane. And then on this side, I'll choose pink. And the last one, 1, 2, 3, 4, 5, 6, 7, 8. Oh, 1, 2, 3, 4, 5, 6, 7, 8. That has 8 carbons. I'm sorry. Yeah, let me start that last one over. Okay, yeah, that has 16. We're good. Yeah, back to pink. So that is a 1, 2, 3, 4 butane. And so I decided on this one. Let me think. I didn't think it would matter which direction to go. But on the paper, I have 2, 2, 3. Let me go back. Okay. Oh, not die. My bad. It's try. Sorry. Okay. Just look at it, make sure that's right. Okay. And so when it comes down to melting points, typically like if a chain has more stacking of like the what are they called, like substituents, it'll have more lattice or more fears in it, which means the melting point would be higher. So I'm going to draw out the structures to show, well, yeah, I'm going to draw out the structures to show that way I don't have to write the names out over again. I'm just going to erase the bottom part. And so I said for melting points, I would say this one has tri, which means it has 3 methyl groups, so I felt like that had more lattice. So that's greater. And then secondly, I would say the one in the middle will come next. It only has 2. And then the first one will come last because it only has 1 group. But after that, let's go over boiling point. So for boiling point, usually like the chain that is the longest and doesn't have many groups on top, which is like kind of opposite, where the melting point would have the highest boiling point. So in this case, we will have this one would be first. I mean, it's the same order that I already have it in display. Okay, so that was boiling point and melting point. Now I'm going to go over the hard part. I'm going to try my best to like draw it out. And then like draw out all the phases, and then I'll label them 1 through 7, or letter them and put them on the graph. So first it wants me to choose the one with the most substitutions, which is the 2,2,3-trimethyl-butane. So let me draw that out. 1, 2, 3, 4. And so this is carbon 1, carbon 2. So a lot of times I try to fully draw it out, like what the actual molecule looks like. That way it's easier to put it in Newman structure. So hydrogen, hydrogen, hydrogen. Or wait, let me just do it a little easier. CH3, CH3, CH3. And so for that part, you're mainly like looking just around this part. Like you're not worried about what's over here. You're just worried about what's around the first carbon. And so the way I do it, sometimes I like to like turn it around sometimes, but like I believe the way I thought about it, sorry, let me just do it over here. I don't like it right there either. I'm a little picky. A little smaller. So mainly it's just methyl groups. CH3, CH3, CH3. That didn't come out great. And then I'm just doing the, oh, sorry. I was gonna say, I want to do the total eclipse first. But right after I figure out what's the other part of this, so this carbon should have a hydrogen above it, and then this one should have a methyl. We should have a methyl here. And so sometimes I don't like specifically putting the hydrogen, sorry, near the top methyl that's on the Newman, because sometimes like I'm so used to seeing like another methyl being with the methyl on top. So I'll just switch it around and just do methyl here. And then I'll do hydrogen here. And then methyl, because you got that and that. So that's the total eclipse, sorry. And so we're gonna just turn it 60 to the right, and that'll get us our new one. But let's just put this one as like, I'm gonna say just TE. Right, TE. And then the next one would be gouge. I always kind of say it wrong, but it's okay. I don't like it. Okay, I guess. Okay. And so the reason why it's called gouge is because it's going away or it's like approaching. Could be spelling that wrong too, but yeah. And so the next one would be eclipse again, because it's basically just the total eclipse, but like in a different format. Oh, that came out way better. Oh, should I do hydrogen? And then sorry, messed that up. Don't like it. Okay, I tried my best. But yeah, this one would be eclipse. Okay, so next will be anti, and the reason why anti will be next because you'll have the two methyl groups far apart. Like the furthest they can possibly be apart would be I believe that's 180 degrees. You have your CH here. So that's the anti. So I hope I have enough room. Let's just try to make that a little bit lower. I'm sorry about I'm thinking wrong. So basically this should be here. CH3 there, and then H will be, so that's just another eclipse, I believe. And then I'll do gouge. So I'll do my CH3, CH3. And so the eclipse is just again behind the, oh wait, not eclipse. I'm sorry. Sometimes I be looking back at the last one I drew, and then I sometimes get a little thrown off. Forgive me. Should be gouge. Okay. Ah. Hydrogen. Try drawing CH3 there. Okay. And then the last one is going to be eclipse. I don't think I'm going to draw it out, but it's going to be just the same one as this one. And so I'll go ahead and letter A, B, C, D, E, F. And then, you know, there's one more. It's one more. It's just this one, you know. So, you know, just take a screenshot of that in your mind, I guess. I don't have that much space, obviously. So, just gonna get rid of everything. And I like pink, so I think I'm just gonna keep it in pink. Energy. I'm sorry, I had already made it to okay. And so, 6, oh, Sorry, it really starts at messed that up. 0, 60, 120, 180, 240, 300, 360. Okay, so usually I try to visualize like how the initial like shape of the graph is supposed to look. Sometimes I get a little confused or like I just forget. But the first one should stop here. Then the next one should be here. Anti is 180, so they'll always be all the way on the bottom. And then right, I feel like something's wrong. Or maybe no, maybe it's just me. Okay. Maybe it's just me. But if there is an issue, like just let me know. Just let me know. And so we said A, B, C, D, E, F, G. But okay, that should be the end of that. Hopefully you guys liked it. Hopefully you guys could read everything. If you made it this far, I appreciate you watching the whole thing. I hope you guys have a good day. Good night.